Alright, so in the last lesson, we managed to put our dice onto the detected plane and make it flush with that plane and look as if we have a real dice on our table. So in this lesson, we're going to make it even more realistic by throwing down the dice and give it a rotational animation so that our dice behaves like a real dice and gives us a random number that we will be able to use. So in order to roll the dice randomly, I will need some random numbers. And you might remember this when we did Dice, one of the first apps that we built in this course. We were able to generate two random numbers that changed the face of two dice. Now, it's slightly more complicated in 3D because in our case, we actually need to rotate our dice along two axes, the x-axis and the z-axis. So to do that, I'm going to create a random number called random x, and it's going to be equal to arc4random uniform, and the upper bound is going to be 4 and shifted up by 1. Now the reason is because I need to be able to rotate it along the x-axis and have all four faces showing up equally likely. So that's why I'm using this line of code to create a random number between 1 and 4. Now the next thing is I'm going to use the result of this random number generation, and I'm going to multiply it by pi over 2. Now, as you remember, we said before that half of pi is 90 degrees. And on our dice, every time we turn it 90 degrees, it means that we show a new face for the top of the dice, which is exactly what we want. Now, Xcode is angry because arc4random uniform, as you remember, creates a integer data type. It's in fact a uint32. So we have to cast this into a float for this to be able to work. So now that we've created random x, I'm going to go and create random z. So I'm going to use exactly the same code. Random z equals arc4random uniform, upper bound is 4, shifted up by 1, and then cast all of this into a float and multiply it by half pi. So the next thing you might wonder is, what about the y-axis? Why are we not specifying a rotation for the y-axis? Well, let me explain. Now, in order for my dice to be able to show all 6 faces, I need it to be able to rotate in the x-axis as well as the z-axis, but I don't actually need it to rotate in the y-axis because it won't change the face that's shown at the top. All right, so now we've got our random degrees of rotation along the x and the z-axis. All we need to do is just to run it as an animation. And SceneKit has this special method called run action that we can use. And we're going to put it onto the dice node that we've added onto the scene view. And we're going to say dice node.runAction, and we're going to use the simplest type where we just specify a scene action. So we're going to say scene action dot rotate by, and I'm going to specify the rotational angle on the x-axis, the rotational angle on the y, the z, and the duration of this animation. So I'm going to choose this one, and I'm going to make this a little bit easier to see by formatting it like this. So the rotation on our x-axis, we've already specified, it's random x. Rotation on the y-axis is going to be 0 because it's not going to change our end outcome. And the rotation on the z-axis is going to be random z. And the duration, let's just say half a second. So let's use 0.5. And rotate by is expecting CG floats, whereas our random x and random z are simply normal floats. So we can cast that into a CG float. And do the same to random z. Okay, so shall we give it a spin? I hope you won't mind the pun. Alright, so that wasn't bad, but don't you think that the rotation seemed a little bit too slow? So one way of doing this is we can actually decrease the duration of our animation. But actually, if you think about it, the problem is that we're only rotating our dice with a random degree either by 90, by 180, 270, or 360, which at maximum is only one full 360 rotation. So that doesn't look like a spinning dice, right? So we can make this look a lot more realistic by simply multiplying our random angle by 5 or by 10 if you really want it to be extreme. And this way, it means that we'll get 5 times 90 or 5 times 180 or 5 times 270, and we will still be able to generate all of the numbers on the dice, but we will go through many more revolutions during this animation and it'll look a lot more interesting. Let me show you. All right, so we're steadily making progress on our dice app, but I want to be able to roll all of the dice that I've placed on the table with a single button. And I want to be able to roll the dice when I shake the app. So that's what we're going to be tackling on the next lesson. So I'll see you there.